Cool, guys. So my name is Dr. K, and today I'm going to be introducing you to Quai Network. What is the goal of Quai Network? It is a scalable proof-of-work blockchain that's designed to serve as a global monetary system. So really the motivation here is, if we look back to Satoshi and Bitcoin and the original white paper, it was to develop peer-to-peer cash. More fundamentally, what he was trying to do is separate money from the state. What we figured out is to sort of accomplish that, you can't just create money or P2P cash. You actually have to create an entirety of a global monetary system. So this means you need something in the system that functions as a store of value, unit of account, and a medium of exchange, and that has to be done on a scalable network that can scale to serve global transactions. So with big goals, we need a great team. So we have people with experience from Apple, Consensus, Circle, Kraken, Deloitte, as well as the University of Texas. And our seed round VCs were Polychain Capital and Alumni Ventures. We also have some great advisors. If anyone knows Stephen Wolfram, the founder and CEO of Wolfram Alpha. Dionys Sendros from Stanford, Professor Cesare, previously of Coinbase, and one of our angels, Andrea. I will point out with Stephen, the reason that he is an advisor is because the way that we have scaled a proof-of-work blockchain is analogous to his fundamental theory of physics. Specifically, we have created a causally invariant multi-way graph, which orders events in a spatial hypergraph. And so if you're interested, we have some podcasts with him discussing how we do this to get to scale. So what do we imagine the world to look like in the future? We imagine the world where a blockchain can do for value what TCP IP did for information. We see that a properly designed blockchain protocol can allow for the trustless and ubiquitous transfers of value, much as TCP IP did that for information. We see that a majority of the world's value will end up circulating on just a handful, if not a single blockchain. This blockchain will need to be able to have financial instruments natively constructed. And we believe that this blockchain must be open, accessible, and most importantly, credibly neutral. So to do that, we need to make a blockchain that is integrated and it can abstract complexity by providing a homogeneous and scalable settlement network. So if we think about sort of the L1, L2 model, you have different security guarantees, but more importantly, you have difficulties abstracting the blockchain away from the user because you're operating in a heterogeneous environment. The system needs to have a dollar equivalent, and we'll go through that in a second, that is not tied to fiat currency. And you need to be able to scale to 50,000 transactions per second. We also believe that the only way to create a credibly neutral blockchain is a proof-of-work consensus mechanism. So let's talk about stablecoins. There's been about 3 product market fits in crypto. Bitcoin showed us that we could have a digital store of value. Ethereum showed that there was a need for smart contracting. And the final sort of real product market fit that has been demonstrated are stablecoins. This is slightly out of date. This is actually over, I think, $210 billion now in terms of total market cap. But the big issue here is that when you use stablecoins on the existing systems, you can suffer from high and variable fees. And just to kind of show an evolution of stablecoins, the most popular ones currently are still fiat-backed custodial stablecoins like Circle and Tether. We've had algorithmic attempts at stablecoins tied to the USD, most sort of popularly Make or Die. And then we've had the evolution of flat coins like Rye. Quai has introduced what we call an energy dollar, which we call Chi in the network. And effectively what we've done is we've figured out a way to use proof-of-work mining as well as market mechanisms within the system to create a token whose value reflects sort of global average energy prices. So we see the current stable coins as actually crypto's sort of Achilles heel. We see this because they suffer from oracle risk, they suffer from custodial risk, and they suffer from credit risk against the issuers. So if we look at when we had Silicon Valley Bank or SVB go under, Circle actually, the issuer of USDC, it decoupled the price of USDC to about 83 cents until the Fed stepped in and insured all deposits of SVB. So the other sort of issue with that too is that because those issuers sort of need access to the traditional financial systems, the regulators actually become large sort of deterministic participants in whatever decentralized system these stablecoins circulate on. So if you want to have a truly independent system, you need to have truly an independent stablecoin alternative that is actually endogenous to the protocol itself. So with Qi, we have a decentralized system. We use proof of mining as oracles. This makes it uncensorable. It makes it independent of the financial system. But because it's proof of work in a blockchain, it's also universally auditable. So this is kind of the construction. Qi is issued through the process of proof of work mining. There's effectively two mechanisms in the system. One is that Qi is issued proportional to hash, and the cost of producing a hash is related to the cost of miners' electricity. The second mechanism in the system is we have an endogenous exchange rate that you can exchange Quai for Qi or Qi for Quai. And that rate is effectively algorithmically set to try to make the market neutral to the offered rate, which then means the internal rate in the system reflects the external rate. With those two mechanisms, you get Qi to converge to the price of production, i.e. the price of electricity. So the point here is that it's censorship resistant, it's completely independent of the system, and it also has cash-like characteristics. I will just stop here for a brief moment and add sort of like a tidbit here. If you look at the economic implications of custodial stablecoins on the chains in which they operate, they don't actually add value. VCs have constructed a term that they call TVL, but TVL isn't market cap. All it does is it potentially creates mechanisms by which that chain can take fee for people that use the stable tokens. But effectively, when a stable token is on Ethereum, Ethereum is just a nouveau version of Visa MasterCard, and they're just able to take sort of that rake on transactions, but that value is not on chain. That value exists in the banking system. If we think about something like Make or Die, that's a debt-based system, any time that you have a decrease in the underlying chain's value, which is the thing backing up that debt, you potentially get sort of cascading liquidations which cause dramatic decreases in price. Qi is fundamentally an asset-based issuance model. So when you create Qi, you're going through the disposition of energy to do so. So you can think of it as an asset, not a debt. And then the other thing that I would point out here is that for Qi to be created, miners must forego the issuance of Quai, because they can either choose Quai or Qi, or a speculator can buy Quai in the market and burn it to mint Qi. What this means is that when Qi is created, it looks like a market buy of Quai in the value of one Qi. So every Qi that's put into the system is actually an accruance of capital in the system against the underlying Quai, which has a very inelastic price curve. So I just encourage you guys to think about the implications of that, because I would actually argue that this sort of asset-based issuance model of a stablecoin alternative is actually potentially as influential in economic design as Bitcoin itself, if you fully can internalize these dynamics. So what are the catalysts for the energy dollar in growth? People want alternatives to fiat. There's currently 23 countries with an inflation rate of more than 20%, and 5 countries that have inflation rates over 100%. People want to spend crypto. We've seen that people like to use USD denominated stable tokens on crypto rails because it gives them wider and easier access to payments and settlements. And then in terms of Qi specifically, people want native risk-off assets. One of the other things here is because Quai is sort of your risk-on DeFi programmable asset, when you couple it with Qi, you can go risk-off. And that means that once value enters the system, no matter if it's a risk-on market or a risk-off market, it never has to leave. Unlike with Bitcoin or Ethereum per se, if you want to go risk off, you fundamentally have to sell your ETH for dollars. Now, there's a number of reasons people might not want to be selling their crypto into dollars or into non-native crypto assets as the markets go from risk on to risk off. So the network, this is just going to be a brief overview of kind of how we scale. So we have a new architecture, a new consensus mechanism, and it establishes a new paradigm of what you can do with a decentralized system. So we can do more than 50,000 transactions per second. We have a sharded topology, and we have also this concept of self-optimized, self-organized subnets. The real thing here for people looking to adopt the chain, if you are sort of a Web 2 or dApp developer, is that you have consistent low fees, and because we can dynamically scale throughput with demand, you'll have that low fee today, tomorrow, and 10 years from now. And we're also EVM compatible with the Quai token. So this is a little bit more of how this works. So this is actually a hierarchy of merge mine blockchain. So we are a mines network, obviously, and this is kind of how we are doing it. But we can parallelize transaction processing. We can reduce the total amount of bandwidth and compute by having shards and subnets. And so we've proven that you can do 7,000 TPS in a 9-shard system, and the requirements for those nodes are equivalent to an Ethereum validator. So if you kind of think about it in the evolution of scaling blockchains, everybody has really been operating in sort of a monolithic setting. So they have a chain, and they're trying to optimize how to get throughput through that chain by either sort of increasing the efficiency by which they compute or reducing the number of nodes that participate in the network. Any techniques that a monolithic chain can use to scale, we can also apply in every one of our shards. The difference is no other system, certainly no other proof of work system, has figured out how to shard, which gives us a scaling access that nobody else can really leverage. And this slide, I'll just mention very briefly, is our new consensus algorithm, proof of entropy minima, but it creates this causally invariant multi-way graph. And this is the mechanism that is so important to be able to do the sharding in a work-based system. Yeah, we can do go-to-market. We can do questions. I don't know where people want to go. Keep going?
Yeah, keep go-to-market.
Okay, sweet. So go-to-market. We're not taking the approach of sort of just trying to get as many developers on the chain as possible. We are targeting specific use cases for specific users that need a characteristic of our system that they can't get anywhere else. So I mentioned one of these briefly, which is having low predictable fees. If you look at Rarible, who is a partner of ours, they're moving their Web 2 business onto our chain because when they go to clients like Mattel, they can't have so unpredictable prices in using a blockchain as they would with something like Ethereum. So if Mattel wants to sort of mint 1 million NFTs, and today it will cost them $10,000, but a year from now it will cost them 100 million, they can't really commit to that as a business. But with our system, because again, we dynamically shard with demand, if it's $10,000 to mint those NFTs today, it'll be $10,000 tomorrow and $10,000 in 10 years, which allows them to commit to using Web3 because they have fixed, predictable costs. We also see the energy dollar as a huge go-to-market. One sort of use case is actually proof of work mining. So if you look at miners, they constantly have to access off-chain traditional financial instruments to hedge their risk of the tokens that they mine. But with Qi, since their costs of mining are predominantly electricity, they can use Qi and they can natively be risk neutral as a miner, and they don't have to create hedged off-chain products. This is also true for people working in AI, in inference, in compute. So Qi creates a great sort of settlement asset for anybody who is exposed to electricity prices and compute. And yeah, we'll just do those two. So just more of the highlighted use cases. We just went through Rarible. We also have something called Quai Pay. We actually rebranded it to Blip. But the idea here is because we can have these low price transactions, we also have this endogenous stable token. There's a go-to-market strategy with our own wallet, as well as integrations with other people in Latin America to get sort of transactional use adoption of Qi. And then these two examples with Lumerin, miners that need to use GPU resources that they sort of aggregate in the cloud and sell. They sort of need a last bidder in the market. So Quai becomes the last bidder for those GPU resources. Lumerin actually allows people to get yield in the system. So there's actually another sort of dynamic in our proof of work mining where miners can choose to defer the reward issuance up to a year. And when they do that, they get more Quai. This creates something that looks like a bond, kind of native within the system. And then you can create secondary protocols. We have two teams doing it right now. We call them liquid mine tokens, but it looks like liquid trading of bonds, very similar to what you would see like a government bond. But it allows people to come and stake capital, which looks just like buying yield. The two things that does for the system is it actually makes GPU mining have security characteristics similar to ASICs based off sort of the capital lockup. And that it also actually defers the inflationary issuance that's related to proof of work mining for up to a year. So you can actually grow the chain without having significant inflation in the monetary policy until after sort of that growth has taken place. You can kind of think of that as like a business taking a loan to grow and then paying it back a year later. This is just some data from our final testnet. I'll just talk about data from mainnet because we started mining on the 4th of February. That's after 7 years, 4 years of research, 3 years of full-time development. We've gotten to a peak of 4 terahash. That's equivalent to $4 million per month actually mining the network, equivalent to about 150,000 GPUs. And just some social data. We have over 200,000 members in our Discord and about 330,000 on Twitter right now. Over 61 community projects, and we did over 1 billion transactions during our testnet. So the network is currently live, and people can go mine, participate, and build applications.
Awesome. I have a question. So on the stablecoin idea, what's the underlying value? Like, so in USDT, you have, treasuries that are backing that. Energy is gone the second it's used. So how does that value get stored so that there's value underlying that token? So I want to understand that piece.
Yeah. So when I think of proof of work, I actually think of gold. So if you think about a gold coin and what gives a gold coin value, it's the fact that gold was relatively equally distributed through the Earth's crust such that there's no sort of easy accessible supply. So when someone shows you 1 ounce of gold, you know that a certain amount of energy and effort was used to create that gold. And that's why you ascribe it that value, which should be roughly related to its cost to produce. So with Qi, it's not about storing energy and then letting that energy go back. It's about having a provable mechanism by which you've created the disposition of a valuable resource in roughly the same amount to get the representative quantity, right? So the sort of value of chi is that sort of provable system. Now, what you may ask is the follow-up would be, well, doesn't Bitcoin do that? And so the difference between chi and Bitcoin is Bitcoin's value is a convolution of many parameters, specifically future expected value, stock to flow, how expensive is it to mine, efficiency of ASICs. What we've tried to do with Chi is remove all of those parameters for the Chi-based token so that you have a perfectly elastic supply that can increase or decrease with demand to keep the cost or the market price of Chi equivalent to the cost of production.
Even though it sounds a little bit like science fiction now, so does everything that becomes reality at a certain point. And with more and more projects starting to pop up where they've got graphene-based energy production and storage and conduction, which is similar to what Tesla and other people said, you could take induction type of energy out of the air. As that starts to come out and brings the price of energy, if it does, towards a trending zero, what happens to the value of an energy-backed token?
That is also a great question. So if we think about competitive commodity goods in our economy, their market price is roughly equivalent to the total amount of energy that went into producing that good in aggregate. So the idea with Chi isn't that it's going to have this strict value. If the energy price goes up or down, the value of those competitive commodity goods will also similarly go up or down. So the idea here is that you're really maintaining consistent purchasing power over time, not necessarily consistent value if energy prices are to dramatically change. That being said, if we look at sort of the volatility of energy prices, it is about 3 times less volatile than the US dollar Canadian pair. So we can use energy, and that's over like 30 years. So we can use energy to price goods, services, and contracts because people can price goods, services, and contracts in the Canadian dollar. But this is less volatile than that. Did you have a question? Raise your hand. No, you're good? Okay, sweet. Any other questions? Those are great questions, guys. Appreciate it.
Thank you.
Oh, one more?
Yeah, I just have a simple question.
There you go.
So we mine all this Chi. Where is the liquidity on the market to sell it back into the market?
Right. So the idea of Chi is that it has not perfect, but ideally approaching perfectly elastic supply. So the way that the market price of Chi converges to the cost of production is that the supply of Chi is always matched to the demand. So the way that that happens is either through producing it by mining or adjusting the supply by either burning Quai and minting Chi or burning Chi and minting Quai. So that allows for elasticity in supply so that the market price can always converge back to the price of production.